So now everything is recorded. Don't ask stupid questions. They will be published to my YouTube channel. So some of you arrived late. So what we did before, we did a little introduction, so that I more or less have a grasp on your knowledge. And we have also proposed 3 topics. Those are listed here. And what we have done is so everybody told me his preference, and we did a little calculation, and we just ended with a discussion whether the vector of 1, 1, 1, 2, 2, 2, 3, 3, 3 is the neutral element in the algebraic term to that calculation. And I thought about it while eating the delicious falafel and delicious hummus outside. And I still think 1, 1, 1, 2, 2, 2, 3, 3, 3 is the neutral element, as well as 1, 1, 2, 2, 3, 3. And as a little homework, if you like, you can. Excuse me? Yeah, so the thing is, the ratio between all the 3 columns will be the same, independently of how many elements you add, and that's why I still think it's the neutral element as well. Whatever. So the thing is, we have the most votes for talk number 1, and equally the same number of votes for 2 and 3. So my idea is I will do all, but I will concentrate on number 1, but I will introduce 2 and 3 at the beginning, so that you kind of get the whole story. And I will do it very casual, so please interrupt me, start discussions with me, add things if you think it adds adds value to the group. Okay, so where to start? Let's start with a bit of Apache Spark, which I actually have stolen from myself. Because those have been in preparation of this course. It's on Coursera, a developer's guide to exploring and visualizing IoT data. And this is part of a specialization which looks like this. So we have another course on Coursera which tells you about how to connect a Raspberry Pi to the cloud and do some basic analytics and send back a command. I actually have one here, but we have also a simulator. So that one is using the Raspberry Pi. Let me double check if the camera picks that as well. Yeah. So that's a Raspberry Pi, and on top of it you see a sense head. So there are different type of heads which a Raspberry Pi can take. And the sense head has an accelerometer, a gyroscope, a magnetoscope, a humidity sensor, a pressure sensor, a temperature sensor, a 4-way joystick, and a 8x8 LED matrix. So that's quite a fun thing. It's called SenseHead. Yeah. And that whole package you can buy at the Raspberry Pi Foundation. So IBM created a learner kit. On just search for learner kit IBM and Raspberry. You should find that. That's one thing. So you see here that first course is already online. So actually 2. But the first data science related is exploring and visualizing IoT data with Apache Spark. And the second one, where we are currently working on, is machine learning on time series IoT data, and that also includes the fog computing and edge computing model, where you actually push analytics to the edge on a Raspberry and on a microcontroller. And then the next one will concentrate on AI and deep learning, and those 3 will form a package and then you get the IBM Watson IoT Data Science degree from Coursera. That's the stuff we are working on at the moment. And from that first course, I just took some of the slides where I introduced you to Apache Spark. So where are those? They are gone. No, here they are. So you see that analytics, very basic, I've done in R, that usually runs on a single operating system process, which is a complete pain most of the times. R is anyway totally slow, and the fact that it mostly runs on only one core doesn't make it better. The same holds if you are doing it in Java. So nobody is using Java out of the box for doing analytics, but since I'm explaining Apache Spark, I just made it up that we start with a single JVM process, and a single JVM process can run multi-threaded. So at least that is given, but it won't run beyond boundaries of systems. So when it comes to Apache Spark, the idea is the single process is only controlling workers or executor virtual machines where your data processing is taking place. And the idea is you just put multiple on the compute node, and then every JVM can pick up a subset of the cores. Or since we are in 2Y hyperthreading, a subset of the virtual cores. So Intel supports 2-way hyperthreading, and Power supports 4 to 8-way hyperthreading. Yes? Excuse me, can you dim the lights, please? Oh, um, okay, so who is interested in Apache Spark? Just take the Coursera course. Yeah? Okay, I will do it faster. So basically, the next step is you scale out. You can put all that executors on multiple nodes, and then you have to have some central coordinator, which is taken care by either Apache Spark itself. That's called a standalone mode, or you can use Mesos or Yarn as a cluster manager to orchestrate those JVM processes. You have two ways of attaching storage. Either you have some storage service, which nowadays is becoming de facto standard because the storage systems are getting so fast that the I/O is not anymore a real bottleneck. But in case you're facing I/O issues, you can use something like HDFS or GPFS, which basically does nothing else than putting normal hard drives to your cluster members, and on top of that you get a virtual file system. That's all. The central data structure in Apache Spark is called Oddity, Resilient Distributed Data Set. It's distributed immutable collection of data, like a Java collection, but it can span the whole main memory on your cluster, and if it doesn't fit in the aggregated main memory of your cluster, it automatically can be spilled to disk. So it's basically an unlimited amount of memory. All operations on RDDs are lazy. That means only when the actual data is needed, data is pulled from the persistent storage. Otherwise, nothing will happen. And the key thing is you won't change your code for processing 1 kilobyte or 1 petabyte because the program is inherently parallel. Let's go to the next. So I skip programming language option because everybody is only using Python anymore. Yeah, it's true. It's true. Yeah, forget about Scala. Scala is so complicated. Sorry for saying that, but you can write Scala code and you will never ever understand it again, unless you do it all day long. You know the guy who invented Scala? Yeah, so his brain exploded, and what was on the wall was Scala. So he will kill me for that statement. But I tweeted it to him. I didn't get a response. So who of you knows functional programming? Okay. The key thing is functional programming in Spark. So the idea is that you basically have a function, and that function can be sent to the data, and that's completely different in the normal way of thinking. So you use an apply function that also can be called map function, and you basically apply the function to your data, and the result is the same as you would have written an iterator, okay, a control structure like a while loop. That the key thing is you can easily parallelize it. You can take the data set, you can partition it, and you can run that same function on each partition in parallel, and you get the same result. That's the key idea. And yeah, blah blah blah. You can look at that if you take the course. Next one is very interesting in my opinion. So Apache Spark introduced the concept of Spark SQL, so you can run Spark queries against RDDs. That's done by wrapping the RDD with another structure called a Dataframe. The data frame has two APIs, relational API. So you can, for example, call, select, or group by on the data frame. Or you can directly create SQL statements against virtual tables. There's something else called dataset, but it's only applicable to Java and Scala. It's stronger typed, it's more performant, but it's beyond this topic because it's not usable in Python, because Python is a dynamically typed language. So there are schemas behind the RDDs, and the schema can either be generated by reading, for example, a JSON file, so it's inferred, or you can define it. By having a schema, you can have an optimizer, because now you're running a relational query against a structured data set, and that means you have a directed acyclic graph, which is the expression of your relational statement. So that results in a logical execution plan which can be optimized and then compiles down to physical execution plans. And based on statistics, you can choose the best physical execution plan. So that's very similar to cost-based optimizers in relational database systems. In addition to that, Project Tungsten is pimping the JVM memory management, because Java Virtual Machine is quite good in executing general purpose code, but the garbage collector sucks, because there's a lot of overhead, and also memory management sucks. As you can see, you have a 4-byte string occupies 48 bytes on the JVM, and garbage collector tries to optimize the object lifecycle, but Spark knows it better. Spark knows which data structure has to be in memory and when not. Therefore, Tungsten uses the unsafe package of the JVM to do memory management itself, like you can do in C++. Some other stuff. So mathematical foundations I won't cover, because I think most of you know them anyway. So let's consider that as a fast track Apache Spark introduction. Let's see what's next. So then another 3 minutes on IoT and the rest on LSTMs, okay? So when it comes to IoT, I only want to show you one thing which you really have to have seen once. Are we getting killed, or is everything okay? Yeah? The security issue and police and so, everything okay? Okay. Yeah. So what you're seeing here is Node-RED. And in order to maybe understand that better, let's give me 1 second to show you something. Yeah, yeah. The Coursera course is free unless you want a certificate, you pay $79. Okay. Only one thing. So in IoT, everybody uses MQTT. So MQTT is an open standard invented by IBM, and is 2003. Since 2003, it's an OASIS standard. So from the device to the cloud, you use MQTT. You have a distributed MQTT message broker taking care of all the fault tolerant, guaranteed exactly once delivery of your messages. You can have a REST API to manage devices and security, and then you basically grab the data and analyze it. And grab the data and analyze it, I usually use Node-RED. Node-RED is an open source data flow editor written in JavaScript running on top of Node.js. This one here is running on top of the IBM cloud, but it runs on every cloud system, on a Raspberry Pi, on your laptop. So you have a lot of connectors and you can install those online in the tool. You can deploy an application in 1 second. You can write, I won't demo it because of time, but you can write a web service in 7 seconds. You can add audit to that web service and writing all requests to a NoSQL database in another 20 seconds. Here I am having a test data generator, which is supposed to run on a Raspberry Pi and actually giving me the real sensor values, but I'm not always carrying that Raspberry Pi with me. So I have the simulator, and you can see here it generates data from a hypothetical washing machine and sends that to the MQTT. Okay. We continue the meetup at the street.
Um, Before everybody leaves, I'd like to ask Romeo when he's going to provide the same presentation somewhere else. I know you're not going to be in San Francisco,
Yeah.
but if it's not the time difference, I might be able to have it live.
Oh, yeah, just subscribe to my YouTube channel. It's just subscribe to my YouTube channel. I will put it on the meetup, and I will announce all my live stream sessions there, and you get notified. So that stuff I'm doing all day long. So.
Yeah, I was just thinking for next meetup, if you guys are interested, hearing what Romeo says, might be not here in US, while he's presenting live somewhere else, we can have him, in our meetup. We all, listen at the same time, or somehow manage to.
Yeah, or you can combine it with other talk or something.
Other talks,
That's a good plan.
Thanks a lot.
Welcome.
Yeah. Thank you so much.
Welcome.
Thank you, guys. Sorry for quick and fast closing.
No, I'll email you.
Yeah,
Thank
just-
you. It was
yeah.
awesome.
Okay.
You sucked. Thank you very much.
You're very welcome. Thank you for coming.
So I help you getting rid of all that.
I'm gonna go to the